All right, Algebra 3 students. So this is coming from module or lesson 1.02. We're looking at properties of rational exponents. Specifically, we're talking about dividing rational exponents. So in the other videos, we talked about multiplying rational exponents, and hopefully you see a connection between the two here. So we're going to start out with a fraction. That's a division, remember, a fraction is division. And so we have in the numerator this a to the fifth, which is just a times a times a times a times a. Whoops, don't need that last one. And in the denominator, we have that a to the third, which means a times a times a. Now, when we have a number, which a is a number, divided by itself, a divided by a, that equals 1. Anytime we have a number divided by itself, it equals 1. So we can actually just cancel those out because now it's 1 times a times a times a times a in the numerator and 1 times a in the denominator. And that's why we're able to cancel those out. And similarly, we can cancel out those and those. So whenever you cancel 1 in the numerator, you cancel 1 in the denominator as well. Now we can rewrite that. So now we have again, 1 times a, which is just a times a in the numerator. And since these all canceled out, we just have 1 in the denominator, which whenever we're dividing, all right, sorry about that, a little glitch in the matrix. What we have here now is a times a over 1. But whenever we're dividing by 1, as I was saying, really we just have whatever's in the numerator. So it's a times a. And we can rewrite that as a squared, because that's what it means to square something, is you're multiplying it by itself. So notice that we can go straight from here to there. That's just fine. We don't need to do this work in the middle, but there's a way to really see it so that it makes more sense. And here's the way that I would do it, is I would rewrite this as a to the power 5 coming from right here in the numerator, the power that is on the base in the numerator, and then 5 subtract 3. The 3 comes from right here. It's the power on the base in the denominator. So it's 5 minus 3, which is equal to a to the power 2, because 5 minus 3 equals 2. So that's how we can always do dividing rational exponents. And notice I have an extra I in my dividing rational exponents. That's pretty funny. There's only one I in dividing. And there's no I in team. All right, so great question, great question. I only want you to go from here to there to there. Oops, it's right there. Yeah. This is all you need to do right there. Great question. Yep. The top is the explanation. Perfect. Thank you. You're helping me out so much. Appreciate it. So what I know is that folks have some fear of fractions. So I highly recommend that you have a look at the fractions supports that are also going to be, I'll put those into the resources. So add fractions. I'm going to remember to do that to the resources. All right. So let's see. The next thing that might be useful for us here is all right, let's look at an example. So I guess one thing I could say is that the more general thing here is a to the power m divided by a to the power n is equal to, and again I'm going to highlight these in the way that I did before, is going to be equal to a to the power m minus n. So no matter what the numbers m and n are, that it will always be done the same way. And so that's really important. Now, I guess something helpful here would be if I did an example with like a fraction. So if we have something like r to the power 6/7, and we're dividing that by r to the power 2/7. So remember, even though these are fractions in the exponents, we're still doing a subtraction. So we're doing r to the power 6/7 minus 2/7. So this is all just now in the power of our base r. And it's actually pretty nice because our fractions, they have the same denominator. That kind of looks like we have two, that's maybe a little clearer. They're just the same in the exponent. We have fractions with the same denominator. And that means that we can actually just do r to the, it's going to be a fraction with a 7 in the denominator because they're the same. And then we do 6 minus 2. And so we can just rewrite that as 4. So this is equal to r to the 4/7 power. Now if I want to rewrite that as a rational expression, we can, I'm going to take these and I'm going to highlight the 4 with pink and the 7 with green, and so we can rewrite it as the denominator of our exponent becomes the root. So we're going to talk about a root 7 of the base remains our base under the root, and the numerator of our fraction that's in the exponent there becomes the power on our base. So if we were told to rewrite this in rational expression form, this would be the answer and these would be our steps. All right. Any questions on that one? Good. So fractions are probably going to be the biggest, scariest thing here, but I don't want you to be scared. You can do it. Go back and have a look at the fractions work if you need some extra help. All right? And we're going to stop there for the video.